Alright guys, welcome to day 2 of 3D printing. Now I gotta make this video in hopefully only one take because we are going to build the Ender 3 today. We'll see. In any case, I got the Ender 3, it's out of the package. I've got everything as it was in the package, just pulled out and set off to the side when I need it. What we're going to do is we're going to build this together, and then I'm going to walk through the anatomy of it as well. Once I'm in the building phase, I'm going to go like that montage mode, so this video should be super long by the time I'm done, but at least we can walk through some pieces. So let's get started. So the first thing I have is the base comes with a major wire and some, when I first pulled these out, I got overwhelmed immediately. This actually isn't too bad. But the problem is that the majority of these cables don't get used until close to the last step. But in any case, I went ahead and put the base plate in the bottom of the frame already on Lazy Susan, so it's a little bit easy to work with, and I can show you some pieces as we go. Now, when it comes to a 3D printer, the Ender 3, we have some cool features that I'm going to start from the bottom up. Is that there should be some rubber feet on the bottom of our 3D printer, and that's because as the printer's going, you don't want any vibrations or, I would say, any disturbances from the outside world affecting the 3D printer or the 3D printer itself. So if you have it on a wobbly surface, kind of like this one is, you're going to run into some issues. So make sure you're on a flat surface when you start printing. But the rubber feet help mitigate some noise that you get from vibrations. Okay, the next thing we have is this convenient little tray. Now, this tray does come all the way out. Super awesome. The V1 doesn't have this, but you can, surprise, surprise, 3D print your own. Tons of people have already done it. All right, so we'll put that back in. And then this port right here is where I would say the most important part of your 3D printer is, and that's the SD card reader. So when we start ready to get our 3D prints ready, we're going to put them into an SD card and then put that port right in there. We can go ahead and rotate around on towards the back. And let's just put these wires right here for now. And if I tilt this up just a little bit, you're going to notice that there is a fuse right here, labels 230 or 115, and that's for either European or American use. What you're going to do is you're going to take a small tool. We can have a bunch of tools in here. Right? You can use a Phillips head, you can use a screwdriver, but in the United States, our outlets work off about 10 volts, so we need to flip this over. Oh, it's too wide. Let's try this again. There it is. There's a screwdriver here. Flip that over to 115 for the United States. That way you don't blow the fuse that's inside the electronic components. You got your standard plug outlet in the back with the rocker switch. You use where that rocker switch is at, you're probably going to use it quite a bit, especially if you don't use your 3D printer every day. It's kind of in an odd spot since it's way in the back, but it's there nonetheless. Okay, now, before you start playing with a bunch of things, we're going to make sure that as we build it, we don't want it to over-tighten any of our screws because we make mistakes, and we'll see if we can make this, I want to get this set up in one solid piece. Sometimes, more often than not, I've had to take a piece off because I either put it in backwards or I would just put in the wrong piece. Okay. Now, let's continue to go. This build plate does move back and forth, and it works part of the 3D printing in one of two directions. So this is the Y direction. Okay. There. I think that's it for now. All right, let's put on our first of our two pieces. And that's going to be, I've got my instructions right here. And we're going to put on our two arms. mounted. And so the next thing we're going to do is we're going to start to build the Z switch motor, the Z axis motor, and with the lead screw as well. Now, before we get too crazy with this, you don't want to take this sleeve off and be touching it too much because most of these do come lubricated and you do want to have a nice smooth action and smooth ground. So I'll take off as much as you need before you get started, but we're actually done with this part for now. So I'm going to move this off and assemble our next part, which is the motor. Alright, so what we've done so far is we've put on our two arms and we put on that Z stepper motor. Now, you notice I had to take this collar off in order to get those screws in there and then slip the collar back on. We're going to go and slide this on there until we need it to be uncovered and ready to move on to our next part. Now, next thing I believe is going to be creating the gantry arm. Now, the gantry arm is, and let's go a little bit, change the shot again. The gantry arm is going to connect, let's go a little bit higher on that, is going to connect across these two pieces right here. But we don't need any of this for now, so I'm going to take this, and it's totally okay to grab by the aluminum extrusion. You do not want to put your fingers all the way around, so you don't want to grab the lead screw as well. So we're able to move this out of our way. And I believe we're going to need some of this metal. Okay. So I'm going to follow along with the instructions we got going on right here. And we're going to build our gantry arm. Now here's what I remember. This is pretty ingenious of them as far as how this works. So notice that I have the correct arm for the gantry. I have to look between the two. The correct arm for the gantry has these drilled holes which allow for hardware to sit in. So look at this nut right here and how it fits in perfectly into that. And I was like, oh, that's just so great. Now, I did have a couple of students realize that you're going to be expected to thread some hardware and screw in here. You're going to stick your Allen key actually through this hole, and it will help you out. You don't have to try to screw it in through kind of this part right here. You can actually go through the top. So let's go ahead and do some of that right now. Alright, now we've got our gantry made most of the way. The picture's a little bit different than what's got going on here. Classic. But in any case, what we're going to do now is we're going to take our gantry that we just made and we're going to slide on the extruder like so. Now this part, this belt, was a pain to get through. It's probably, I would say, the only annoying step. And then, because that belt then attaches to the extruders, if we go to this underside right here, we can then attach the belt. Now the belt is pretty loose because I do not have the tensioner on the other side on, but so you want to attach this in such a way that there is almost no slack or no excess right here. Because when we put the tensioner on the other side, and we get that fixated, there's not going to be a crazy amount of wiggle room. And you can only see, like, I've already got not much room over here to throw that tensioner knob in. Alright, we have our gantry fully assembled, but we need to position it on our bed correctly. So I have to reorient this just a little bit. And here we go. Now, don't worry about these tensioner knobs too much. We're going to talk more about those later. We just want to make sure that first we're going to take our sleeve off the screws. And we're going to start to slide and put this thing together. And there we go, folks. We've got our gantry arm installed. Okay, not sure what's next, but let's check to see what we got on here. So we got the tensioner, we got the gantry arm on. Now we're moving on to our other arm, which is going to hopefully hold this whole thing square. Now, notice that there's a little bit of profile cut out on the top edge of this top arm, and that's to hide the bolts so our other pieces can slide appropriately. So that's going to be what is going to be. Now we're going to put our user interface in, but this piece is going to slide out. It's going to make a little bit of a loud bang, and we're just going to slide this plastic housing off. That way we can install this piece a little easier. If you don't, this sometimes slides off when you're in the middle of installing it and it'll crash and hit the floor. So we're just going to prevent that from happening. Alright. If you've never dealt with aluminum extrusion, these little T-nuts slide in super easily into these grooves. So to do that, we're going to pop off this plate. And then these aren't loose enough for us to get started. So we're going to loosen them up a little bit and go ahead and install that in. Now, before I slide this on, we're going to go ahead and connect the user interface together with our electronics. and then that slides back. Like so. We're gonna grab our plates, pop our faceplate right back on. Filament holder has a little pop-off screw nut off on the end. You can insert that in. Cool thing is that this is reversible, so based upon how your setup goes, what's in the way, you can kind of put this filament arm wherever you want. Now by default, most people put them up top, which can be okay. I should be facing this way now. Most people put them up top, which is okay. I've even done it where I have them on the side sometimes. That's a little easier to feed into the filament. But for now, we are actually, you know what? Put it on the side. I think it's what I'm gonna do. White filament, especially cheap white filament, is the worst. It likes to snap. It doesn't play well. I'm gonna go ahead and toss it. Now, some of you might be wondering why I put the arm off to the side rather than on top. Is because how the filament is fed through, I really don't like it coming out through the top. It just creates too much of a bend. Sometimes if you have a cheap filament, it snaps. However, since a lot of the printing that I'm going to be doing on this channel is pretty small compared to the total size of the printer, that feed path is going to look a little bit less stressful. So let's see if we can zoom in. So that feed path is going to be directly from the roll of filament into our stepper motor right here for the extruder, and then that pushes through our tube. Rather than feeding all the way from the top, and then looping around and just creating less stress. So I like it here, you do what you want, but I'm moving forward. This little knob kind of looks like the little Iron Man logo. In any case, that goes right on top. Fits in nice and neat. It actually does a really good job of showing you if the extruder is actually moving or not. It's a good indicator of if things are working as expected. Okay, before I get too far ahead of myself, let's finish the instructions. Okay, last step is to connect all of our electronics and our Bowden tube. So this tube is going to push into this nut here. Now the way this works is that it will, when you push in, it'll grab it, but you want it to where it doesn't pull out, where it doesn't slip out, and that's where this little piece, this little blue piece, comes in handy, and it'll clip on onto the outside. It helps prevent this Bowden tube from slipping out. Just give it a nice little tug to make sure it doesn't fall out, and we're looking good. We're actually going to upgrade this pretty quickly because one of the first upgrade kits we're going to do replaces some of these components, and I just really like how it looks, and it ups the quality just a little bit. All right, now let's plug in some of our electronics. Now, it does a really cool job of telling you which one goes to where based upon the tags on the electronics. Also, most of them are different as in their size and their length, but they do tell you where things go. I'm going to get this off for now. That will smack myself in the face on to it. The very first step. A Z limit switch. I didn't put that on. Now that's not going to be too totally, let's say, detrimental, because since this is 18 of it, everything's going to be okay. All right. Z-axis limit switch. Way. Now, when it comes to the limit switch for the Z-axis, we're probably going to have to adjust this one anyways once we do our first set of calibrations, just because it is the one that you have the most amount of adjustment in as far as where your Z-axis goes compared to the bell. We are not going to go too crazy with calibrations today, but we just want to get things. All right, first time turning on. She's alive, folks. And there we go. We've assembled our 3D printers. The rocker switch on the back, so we just turn it on. Notice the fans are going to kick on. Now, the fans, they shouldn't rattle. You should hear them kind of kick on, and then sometimes we'll even power it down. But I'm going to go ahead and turn these off. Okay, so let's continue talking about this 3D printer anatomy. I'm going to unplug the power cable, scoot this back a little bit, change your camera angle, and then let's walk through the rest of the anatomy of the 3D printer. What kind of talking about? We talked about the bed. We talked about where we're going to put all of our little tools in down here at the bottom. Okay. We've got this user interface. Looks great. It is detachable. Reasons we'll get to. You've got your plug-in on the back side. You've got your rocker switch. And of course your plug-in, where it's going to be plugged in. Now let's talk about the rest of the anatomy. So you have 3 motors that work in the X, Y, and Z direction. Now those are stepper motors, and they are rather accurate because of the voltage determines the position the motor goes into it as it spins freely after it's applied some voltage. It's very particular. Since it's particular, we really don't need these belts to necessarily drive precision. They're just to drive whatever they're moving. These belts have some wires, some cabling in them, so they don't stretch too much. So when it comes to tensioning these, what I do is I kind of just give it, tighten it to where it's no longer loose, and then just give it a little bit more. And that tends to work just fine as far as tensioning. When it comes to the belts, I really don't touch these too much unless they are really, really, really loose. You can get very particular and looking at how accurate can we get with this Ender 3. Messing with the tensioner belts will get you there, but I'm not going to do that. Okay, so now we've got our 3-step motors. One, we got 2, and then there's one kind of hidden in the back, and then there's 3. Next to each of those stepper motors is a limit switch. So this little switch right here. If in any instance this limit switch is stuck, or doesn't activate, the machine will have a hard time of figuring where it's at. So one of my degrees was not going correctly towards home. It was grinding and like, So what I found out is that one of these limit switches were stuck. Anyways, so next to the motors, you have limit switches. You got one, you got two, and you have the third one back here. It's kind of hidden. Let's slide this bed forward right here. When you're leveling your bed, you want to make sure that you do not get in the way of hitting this. So if your bed's too low, it'll clip into it. And definitely not getting in the way of your limit switch. Okay, so we got the 3 motors, we got our limit switches. Now let's talk about the bed. Now this bed has a couple of clips on it. These clips do come out. I'm actually going to have to take them off because we have to take this plastic coating off. So we got the 2 clips that came out, and we're going to go ahead and take this coating off. One side of this bed is corundum, if I'm pronouncing that correctly, and it has a very, very small, I would say porous-like or almost like Swiss cheese-like texture, and the flip side of it is a solid glass plate. Now you can use both sides of these. If you want a nice finish on your bottom layer, you can kind of use this. This is more advanced stuff. And if you want kind of an easier time, you can use this corundum bedside. It will get ugly over time, so do be prepared for that. Okay, and then we're going to go ahead and slide in with our corundum glass facing up. Go ahead and put one clip in the front. I was always so nervous when I was first putting these on, but after I realized how tough this glass is, I tend not to have a problem. Okay, so we got our glass bed. Behind the glass bed, we have our heater. Now this is going to heat up the bed to a certain temperature. That bed heating causes some really good adhesion there. So it's a really necessary component for a decent 3D printer. If it doesn't have a heated bed, you're just going to be in for a bad time. So this is the heater, that heats the bed. And then we have where the magic comes from. So we put a roll of filament up here. Put a roll of filament up here. This filament is going to feed from this arm into the back of the extruder right here. Now, this part is a little bit tricky to get into, and so what I found out is it takes a little bit of time of figuring out, but you're going to hold down this arm. That'll free up the mechanisms on the inside, and then you can feed your filament through. Okay, so this motor controls the filament into a Bowden tube. This Bowden tube then feeds into our extruder. Our extruder has it inside of here. It's called hot end. Now, hot end, surprise, surprise, it's hot. Your hot end then kind of works like a glue gun, as then there's mechanical pressure behind, and then hot end gets warm and then pushes out your filament as expected. Okay. There are a couple of upgrades you can do. You can go from a Bowden tube to a direct drive filament 3D printer. I haven't seen anything that makes me think it's worth the money right now, but maybe we'll dive into that later. Another thing that can be, I would say, more helpful for accurate 3D prints is at one point we're going to see about, instead of having one screw here, of having two screws to control this gantry arm. Because after a while, and this one looks really good, it doesn't have much of a wiggle. After a while, this gantry arm can have a little bit of a wiggle to it, and so that can cause some irregularities in your prints. But in any case, guys, there we go. We have, oh, you know what, I didn't even talk about it. When we go with bed leveling, probably sometime in the next video here, we're going to talk about these bed leveling nuts and how we use them to level our bed and kind of best practices when leveling your bed. Okay? Alright guys, that took me an hour and 20 minutes. And that was probably because I was talking while I was building it. You should be able to build this in under an hour. especially if you do it probably more effective. In any case, hope this video has been helpful. Take care. I'll see you guys in the next video. Adios.